Hello guys, today we will learn about the equivalent diagram, or we can say the block diagram reduction control engineering. So there are some basic set of rules by which we can draw the equivalent diagram for any given diagram in the particular questions. So the first rule is the combining block in cascades. So what is the basic concept of this cascading? So as we know that in cascading we are either joining the two blocks. So in this case we will be having two gainers where x1 will be the input signal into the g1 gainer, and we will be having one more gainer g2. So whenever we are having two gainers which are attached in series, the gainers get multiplied. So the signal x2 will have the value x1 g1 g2. That means the input signal get gained by g1 g2 product. Now what will be the equivalent circuit for this particular diagram? As the total gain is the product g1 g2, so we can directly add, or we can directly modify the given diagram with only one gain, which will have the value g1 g2, and the output signal will be x2. Now the second rule. In second rule we are moving the summing point after the block. After the block means the block is the gain which is given in a diagram. So our diagram will be like this, will be the summing, and we will be having an input signal x1 and we will be having an input signal x2. This will be attached in series with a gain and will give an output signal x2. So after the signal comes from this summing, here the value of the signal will be x1 minus plus x2. Now when this signal becomes the input signal for this gainer, and finally what we'll be having for x2 is x1 minus plus x2 into g. So now we will be drawing the equivalent diagram for this given block diagram. The equivalent diagram will be, as we have stated in heading, that we are moving the summing point after the block. So here is the block and here is the summing point. Okay, so we will be drawing firstly the input and the output, and like in this the summing was having an input signal x2, so we will draw an input signal x2 here and we will give the input signal x1 here. Okay, so the outcome of this gainer will be x1 into g. Okay, and after that always remember that whenever we are moving any point after a block or before a block, that means we are modifying the input signal. So suppose this input signal has the value x. Okay, sorry, I did a mistake. This is, let's suppose y, and this will be y. Yeah, now it's correct. So here we will having an output signal y. So now we have to, we know that the signal y is actually should be equal to x1 minus plus x2 into g, because the equivalent diagram says that whatever we are having the output in the basic diagram should be equal to into the equivalent diagram. So here we are having the input x1g, this one. This is minus plus into x2 into small x. Now this should be equals to y. So what is y? Y is x1 minus plus x2 into g. So from this and this we comes to know that the small x should be g. So we came to know that the value of this gainer should be g. So this will be the equivalent circuit or equivalent block diagram. So now the third rule is moving the summing point ahead of the block. What is block? Block is the gain. Okay. So in this case we will be having the initial diagram with G, and we are having a summing or summer, and the input signal is x1 and the input signal to this summer is x2. So at this point the value will be x1 into g, which get added or subtracted to this x2, and the resultant y signal will be x1g minus plus x2. So this is the resultant signal or the output signal. So now the equivalent diagram for this will be, actually we have to move the summing point ahead of the block. So summing point should be moved ahead of the block. Here will be the summing point. And as we discussed in this, whenever we are moving this point ahead or after the block, then that means we are modifying the signal here with a value x. Here the input is x2, the input is x1, here is the gainer g, and the output signal is y. Okay, now x1, the value here for this whole set will be x1 minus plus small x of x2, because this block is a gainer block having a value x, which we have to calculate. And this is multiplied by g, and this will be equals to y. The whole set is multiplied by g, because this is also a gainer, and this will be the value for the y. So y, as seen from the initial diagram, we were having x1g minus plus x2. So from here we can calculate the value of small x. The small x should be equals to 1 upon g. So that means the gainer is having value 1 upon g. So this will be the equivalent block diagram for the given diagram. Now let's come to the fourth point. So the fourth rule is moving a takeoff point after the block. So guys, what is this takeoff point? The takeoff point is used to allow a signal to be used by more than one block or the summing point. So that means if we are having an input signal x1, and here we can have a takeoff point. So this will be the takeoff point, and from this point we can have a supply of x1 to some other summer or to any other block. So this value will be equals to x1, and here we will be having a gainer, and this will be simple. X1 into g will gives the output as x1g. So now we will draw the equivalent diagram for this. The equivalent diagram will be, actually we have to take the takeoff point after the block. So the block will came, and then the takeoff point will came. And when, as we have discussed, whenever we move anything ahead or after the block, we have to modify the signal. So in this case we will be adding a block, and this will be the signal x1. This is the signal input x1, and here we have x1 into g. So at this point also we are having the value as x1 into g. So what should be the value of this gainer x? That the value is x1, because in initial diagram we were having the supply as x1, so the equivalent should also have the same value as x1. So x1 into x should be equals to this is multiplied by g, because the gainer is here. So this should be equals to x1, because we were having the initial input to any other block or summing as x1. So from here we can have the value of x as 1 by g. So this value is 1 by g. Hence this is the equivalent diagram for the takeoff point after the block. Now let's move to the fifth rule, which is moving the takeoff point ahead of the block. So in this case we are having an initial block diagram as this gainer g, and here is the takeoff point, and from takeoff point we can have a supply which will be equal to, this is x1, this is g, this is x1g, and the output is also x1g. So the equivalent diagram will be takeoff point is ahead of the gainer, the input is x1, the output is x1g, and whenever we move the takeoff point or any summing point, we have to modify the signal. So here we will be having a block, and this will be equals to, let's suppose this is equal to x. Okay, so the value should be equals to x1g. The value should be equals to x1 into g. So what is the value of this x? So the value should be equal to x1g. So x1 into x is equal to x1 into g. So x will be equals to g. So the value of this block is g. So this is the equivalent diagram for the given block diagram. Now the last is the very common rule and is very important rule which we have to use in all the numericals for this control engineering. This is eliminating the feedback loop. As we know, there are very many pros for the feedback loop or the closed loop. Also we can say as the closed loop. Okay, so we are having the diagram as the summer. Here we are having a feedback of h. Here is we are having a block g, and the output is x2, the input is x1. So the basic, or you have to learn by heart for this, that we can modify this by just putting one gainer having the value 1 upon g upon 1 minus plus g into h. The output will be x2 and the input will be x1. Also we know that the transfer function is output upon input, so it will be equals to g upon 1 minus plus g into h. So this is all the 6 rules which you can apply for any equivalent diagram. Hope you like this video, and if you are having any queries related to these 6 basic rules, you can comment in the YouTube channel. Kindly subscribe and like this video. Thanks a lot.